which means secant is going to have asymptotes as well. Secant, since it has cosine in the bottom, which cosine is x, means it's going to have the same asymptotes as which one, tangent or cotangent? Which one of those has x in the bottom? Tangent? Tangent? Which means secant and tangent are always going to have the same asymptotes, except for period change. Which means I can say I know my asymptotes are going to be where cosine of x equals 0, or where 1 over cosine of x is undefined. Which means cosine is x, x is undefined, or x is 0 on the y-axis. So I'm going to have asymptotes at negative pi halves, and pi halves, and 3 pi halves, and so on and so forth. Just like tangent. Tangent and secant. They're buddies. They are. They have the same asymptotes. So mathematically, we could say the asymptotes are at multiples of pi halves. Could I say this? Could I say at any multiple of pi halves? Pi half? Nope, that's not true. That's what I mean to say. At pi halves plus any multiple of pi. Because if I'm at pi halves on my unit circle and I add pi, do you agree I'll be at 3 pi halves? And if I add pi again, and I add pi, and I add pi, that's not a very good circle. But if we were going to write the domain of this out, that's what we would say. Like, we would say the domain is everywhere but where there's an asymptote. And that's the fancy way of saying asymptote. Really fancy, we could say where n is an integer, and this is the symbol for integers. There you go. Now you can feel like you're in the class I'm in, where we n is an element of integers. I know it's weird, right? We could say this. There uniquely exists. I learned that in my class.
What does that mean?
There uniquely exists.
So what is the measure?
This means, like, see, like I put an n up here, so I need to say what n is, right? This means where n is an integer. N is an element of the integers. Which means it can't be a fraction or decimal. That's what integer means.
Yeah,
N is an integer. That's really what you could say. Math people don't like to write any words out. That's what I've learned in my class.
what does the 3 dots mean? The triangle with the dots?
In conclusion,
Yeah.
I forget which way it goes though. Like this?
I've said it works either way.
Like this. I think it's this one. So like at the end of our proofs in class, he writes this. And then he writes something. So like in conclusion, in summary.
Do you think I would get points for it on my English history test?
Probably not. So let's draw our asymptotes in. Negative pi halves. Pi halves. Oh, I did not do a very good job of making that equally spaced. 3 pi halves. Negative 3 pi halves. Two. That's what we like to graph, right? 2 periods. Nope. This will be 2. Bear with me. So let's use what we know about cosine to maybe make it easy to find our values of secant. At 0, what is the cosine of 0? One. We really got to know this, kids. We got to know cosine is x. We got to know at 0, right here, we're at the point 1, 0. Right? So cosine of 0 is 1, which means secant of 0 is just the reciprocal of 1, which we learned yesterday is also 1. So let's think for a minute about what cosine looks like, if we remember. What does cosine look like? Olivia says this. You don't have to graph this, but let me just remind you. I'm going to do it in black, so it's like the background. Cosine starts at 1, and then what usually happens? When it gets to pi halves, what happens? It goes to 0, and then cosine of pi goes to -1, then it goes back to 0, and then back up to 1, right? Remember, this is one period of cosine?
Oh yeah, I like these.
This is cosine of x. I want to graph the reciprocal of that. I'm going to go this way. Oh, dang it.
Try not draw the circle. So don't draw this.
I don't know. We'll see in a minute. Don't draw yet. Trying to get you to visualize something here. The problem is, if you don't know what cosine looks like, it's hard to visualize this. We could just pick some points here, but here's what I want you to realize. Secant is the reciprocal of cosine. So if you just look in between these two asymptotes, what would the reciprocal of this graph look like? I just took this and flipped it up.
Like this.
You got it.
No way, it wouldn't be an M.
It would not be an M because there's asymptotes.
It'd be like this.
It's not going to touch there.
It'd be like this, right? On the left and right side.
So it's just going to take what's in between the asymptotes, what normally cosine is, and you could flip it up. If you're not sure, we could pick some points here, right? Like the cosine of pi thirds is 1/2, right? So the reciprocal of that would be 2. So at pi thirds, this would be up to 2. But what I like to do is I just flip them over. Like they kind of become parabolas. Not really, but there's asymptotes there. So this one, when I flip this over, right, it's still going to be at -1, but now it's just going to flip down like this. Still going to be at 2 pi. That's totally not 2 pi. It would be like this, but it stopped, right?
Now we can draw it.
You tell me, which one is the secant? The secant is the red graph. The black graph is cosine, right? So secant does not contain both of these. That would not be a function anymore. But the red graph is secant, which means it kind of looks like a bunch of parabolas. But the reason it looks like that is because it is the reciprocal of cosine. But everywhere that cosine is 0, there's an asymptote. So that's what makes it broken up into sections. So for me, secant and cosecant are my easiest ones to do because I compare them to sine and cosine. But if you don't know what sine and cosine look like, secant and cosecant seem almost impossible to graph, which means you'd have to just pick a bunch of points. One period is when you get back to where you started, which means like you need 2 sets of asymptotes, right? Like we have this to this, and then we need to get back up here to get one full period. So I think we still say the period is 2 pi, just like sine and cosine. So tangent and cotangent are our only functions that have a different period, which is pi over b. Notice the range of this is the exact opposite range of cosine. Cosine was stuck only between -1 and 1, but secant is everywhere but -1 and 1. Do you agree with me on that on the y-axis? So it's like everywhere but where cosine is. What do you think cosecant is going to look like? The same thing, except for different asymptotes. Still going to be the reciprocal of sine, which is, as Oliviero says, flipping over the parabolas. So cosecant is 1 over sine, which means my asymptotes are going to be where sine is equal to 0, which is the x-axis, which means I'm going to get things like 0, pi, 2 pi, 3 pi, just like cotangent, because cotangent has sine in the bottom, cosecant has sine in the bottom. So cosecant and cotangent are friends. They have the same asymptotes. So we can say the equation for the asymptotes are just multiples of pi, where n is an integer. Integers.
Why is it extra line?
That's just how you say it. Where n is an integer. You can just say where n is an integer, right? You could just say where n is an integer. A lot of times we say this, where n is a real number, right? But we're not wanting real numbers. We want only integers. So let's do 2 pi to 2 pi. I'm going to just go ahead and graph sine here for you, just to remind you what we did last week, all of last week. When we graph sine at 0, what is sine? 0. And remember, it goes up and then down and then back at 0, right? So it goes up to 1, down to 0, down to -1, back to 0. I say 1 hump up, 1 hump down. That's sine, not cosecant. And then over here, it's the exact opposite. So it goes down first, through 0, back up to 1, back to 0. Everywhere that sine equals 0, cosecant has to be undefined, because if you flip 0 over, you now have 0 on the bottom. So that's why all of our asymptotes are at multiples of pi, because if you look at this, that's where sine equals 0. So that's where our asymptotes are going to be like cotangent. So I can draw in my red graph here, which is the actual graph of cosecant. And when you make your graphs on your papers, if you draw the sine graph in as your background, you have to go back and erase it. Like, you can't leave both graphs on the same graph. You have to show me that, or label them. Label one as sine and one as cosecant. But I just like to do it on this first one. I won't do it on the normal ones. But I just like to do it on here to show you that it's just flipping it over. The highs and low points are the same, like the max and mins. So like every place that sine equals 1, cosecant would equal 1, right? Because the reciprocal of 1 is 1. The reciprocal of -1 is -1. So those highs and lows are the same. And then it really is just flipping it over that point. So that's why they end up kind of looking like parabolas. The asymptotes are what make them keep going, because they're going to get closer and closer to those asymptotes. So I don't graph a lot of points on this, just because the asymptotes help me bound them. But you can see secant and cosecant are very easily mixed up as well, because they look very similar. But the asymptotes are different, and so that's the part that you really have to make sure that you're learning. And so I'm going to go back and erase my sine graph now. What would happen if there's a number out in front of cosecant, like a 3? What's that going to do? Yeah, so instead of being at 1 and -1 on the y-axis, you'd be up to 3 and -3. So it's just moving those up. The period can change, just like with tangent and cotangent. So if the period changes, the asymptotes change. So that's where we want to write out the rules for how do we find the asymptotes. Just like with all the other graphs, I'm not going to make you graph any by hand with a phase shift, but I will make you find some asymptotes with a phase shift, just because it's harder math to do. Like, you know, the graph, then you just have to find them. Questions about this? These look kind of not great, but compared to the other ones, like, I feel like it kind of just flows together. Oh, the asymptotes are the same. Oh, it's just the reciprocal of sine and cosine. So here's what you need to be able to find. 2 consecutive asymptotes. That means 2 asymptotes that are right together, right? So you need to know which ones to set equal, right? Like Ariel asked, how do I know whether I set it equal to 0 and pi, or pi halves and negative pi halves? Because you got to think about what's in the bottom. So tangent, let's do y equals tangent of, we're going to say bx minus c. And tangent is y over x. So it's good buddy secant, right? Those are going to go together. I think about it to think about which ones go together. Like for me, I think about tangent. You can write tangent, remember, as sine over cosine. You can write secant as 1 over cosine. So since they both have cosine in the bottom, this is why their asymptotes are the same. And their asymptotes are where cosine equals 0, which means you're going to set bx minus c equal to negative pi halves and pi halves every time and solve that to get your 2 consecutive asymptotes. Which means cotangent and cosecant are also going to have the same asymptotes, yes? And again, how can you check? It's like you have to memorize this, like you can just think it through. Cotangent is the same as saying cosine over sine, and cosecant is the same as 1 over sine. So since they both have sine in the bottom, that's why to find their asymptotes you do the same thing. It's undefined where sine equals 0, which is on the x-axis. So to find their 2 consecutive asymptotes, you set that equal to 0, and you set that equal to pi. This is just the way I tell you to do it, because it's just a nice, easy formula. There are other equations you can set, like other things you can set it equal to. You agree that pi and 2 pi would also be 2 consecutive asymptotes? Or 3 pi and 4 pi? You can. I just feel like I always pick, these are the ones I always pick, so this is what I teach you. But as long as you give me 2 consecutive ones, that's what I'm looking for. They have to be next to each other. If you find 2 consecutive ones, you can always do together. So when you're graphing any of these, this is where you have to start. But also, when we have a test, I'm going to ask you some questions that just say find 2 consecutive asymptotes to see if you know how to set this up and solve it, that you don't have to graph. So look at the next example here. Find 2 consecutive asymptotes. A question like number 3, I would never give you to graph by hand. You could do it, but I wouldn't make you graph one with a phase shift by hand. We will look at these on the calculator and how the calculator graphs asymptotes. But on the test, we won't graph these by hand. But I do want you to be able to find 2 consecutive asymptotes. So you have to know, I should really have like equals y on this. You have to know secant is 1 over cosine. So where does cosine equal 0? Negative pi halves and pi halves, right? So I'm going to take this, 4x minus pi, and I'm going to set it equal to negative pi halves, and 4x minus pi equals 2 pi halves. That's step 1. You got to know what to set it equal to. Then step 2, which turns out to be the hard part for a lot of people, you got to be able to solve that for x correctly. So do you agree I'm going to add pi first? Yes. And since this is negative 1/2 pi and this is plus 1 pi, I can add those together because they both have a pi in them, right? So if I have 1 pi minus 1/2 pi, that's just going to equal 1/2 pi. Do you agree with that? But if things have pi in them, you can always just take the numbers and then put pi back with it. But negative 1/2 plus 1 is 1/2 pi, or pi halves. And then what am I going to do? Divide by 4, which is the same as multiplying by 1/4. I'm just going to say this, right? Which means I would get pi 8 as an asymptote. When there's no phase shift, the other one's just going to be the positive one, right? But when you're adding something, you actually have to add it and do the math separately. So don't just say negative pi 8 over here, because that's what people tend to do. But watch what happens. When I add pi over here, what is pi halves plus pi? 3 pi halves, right? 1/2 plus 1. And then when I divide by 4, still the same as multiplying by 1/4, I get 3 pi 8. Which means if I was going to graph this, my first 2 asymptotes I would graph would be at pi 8s and 3 pi 8s. And I would still do the same thing. I could do half of it and half of it again, but because it's shifted over like that, I don't make you graph those by hand. But this is what you would circle. Your asymptotes are equations. This one I could make you graph. Cosecant of 3x, all we've done here is change the period, change the asymptotes. But cosecant has sine on the bottom. So you have to know if sine's on the bottom, it's where does sine equal 0, which is at 0 and at pi, which are much easier to solve, right? You just get x equals 0 and x equals pi thirds, and then I could actually graph that. Questions on that? So what else do I have? More into the stuff like you did in yesterday's homework, using your calculator for 4-day 1 stuff. Kind of like number 40 that we just did. Solve over the given interval, give an exact answer when possible. I can't give an exact answer if it's 1.2. What would I have to type in on my calculator to get one answer? Secant is 1 over cosine, so we could say that means cosine is 1 over 1.2, right? So if it's not sine, cosine, or tangent, you have to do the 1 over. And then on my calculator, in radian mode, I'm going to type that in. Inverse cosine, 1 divided by 1.2. I get 0.59 if I round to 2 decimals. Is that true? Are secant and cosine positive in quadrant 1? Should I get an answer in quadrant 1? Definitely true. Somewhere. My angles always look the same. It doesn't matter if it's actually drawn correctly as long as it's in the right quadrant. I pretty much always draw almost a 45-degree angle here. But that means in quadrant 1, there's an angle of 0.59. What other quadrant are cosine and secant positive in? Cosine is x, yes? So when x is positive, it has to be in quadrant 4. Cosine is negative over here. So you got to be able to find the other quadrant, and then you got to be able to find that angle. It's going to be the same distance away here from the x-axis. So what math could I do there to figure out what would be measured from here all the way around to here? From what? 2 pi minus 0.59? Do you agree with that? That would give me a quadrant 4 angle there. So I want to go from 0 all the way around except for take that away. So 2 pi minus 0.59 would give me an answer of like 5.69. Calculator and no calculator part of the test, we are going to see questions like this. So which is why I spent time on it for 4-day 1, time today. On your homework today, just like yesterday, only there's secant and cosecant. So there's going to be some matching, there's going to be some graphing, and then there's going to be some at the end with secant and cosecant. So it's almost the same number of problems, just the ones with secant and cosecant. I believe you have to graph like 3 of them, like you had 2 yesterday. 7, 8, 11. Yeah. Well, 4 of them. Find your asymptotes, label it, and see if you can get those graphed, and we'll talk about them tomorrow. We're going to do a worksheet over 4.4 and 4.5 tomorrow, like almost, maybe you can call it a packet because it's stapled. That's exciting, right? Some good practice graphing tomorrow. And then Thursday, we will look at some graphic calculator stuff. And then we're going to move on to 4.6. We skipped 4, or just kidding, 4.7. We skipped 4.6. So we'll move on to 4.7 on Friday. 4.6 is kind of cool, but 4.7. You actually have a couple minutes, so if you